Good morning, everyone. Welcome to the class. This is Modern Physics lecture number 2. Do you recollect what we were doing in lecture number 1? What we are doing in the last class? Don't remember?
Quantum theory.
Quantum theory. Okay, I give you that. Remember, bacha, in physics.
Perfectly reflector surface.
Okay, good. In physics, what is important that you, when you in preparing for NEET or in biology or chemistry, remember one thing that is very important, and it is becomes the most important thing in physics. Whenever you come to the class, you must always 10 minutes before the class or maybe the night before the class, you should always go and have a look at the notes, or in this case, you also have the lecture.
Okay,
Have
sir.
a look at the lecture before coming on to the next class, because every other class is a continuation of the previous class. So if you don't remember what we had done in the previous class, this class becomes null and void. It does not make any sense. If you want to make any sense out of this class, you have to go back and see what we did in the previous class. Is that okay?
Okay, sir.
So even if you don't recollect it, let me help you out with recollecting it. We had seen photoelectric effect. This is the first time we are doing it. I'll just give you a summary after at the beginning of every class what we have done. We have done in the previous class, we have seen what is photoelectric effect when light of sufficient energy falls on any surface, particularly in case of some photosensitive metals or photosensitive substances. This light is nothing but photons. They have energy. This will be able to eject electrons. This phenomena is known as photoelectric effect. The electrons are known as photoelectrons, and the current is known as photoelectric current. Light has dual nature, particle as well as wave. Here we are dealing with the particle nature of light. Light consists of small packets. One packet is known as photon. What is the energy of a photon? What is the energy E of a photon?
1.6 into 10 to the power of minus 19.
See that this is what happens when you don't go back, when you don't study before coming into the class. You're all lost, and sending SOS messages. You know the meaning of SOS? SOS message. I'm a marine engineer. By my padhai that I have done, SOS. You know SOS message? SOS? SOS stands for Save Our Souls. Almighty God, please come and save our souls. Save our souls. When the ship is abandoned and when you're caught in the deep sea, you send SOS messages. Save our souls. Because then you are praying to the Almighty. Send someone to help us. Now, if you are sending SOS messages in the physics class, just because you don't remember what we have done in the previous class, well, the God is not going to help you. Okay? God will not help you. If you don't remember what we have done in the previous class, I give you 5 minutes. 5 minutes and you go back. You go back in the past. How will you go back in the past? You don't have a time machine. Well, you have your notes. That's your time machine. So become Doraemons. Get into your time machine. That's your notes. Read it. I'll give you 5 minutes and then come back. I'm here. I'm giving you 5 minutes to read the notes. Come back. Then let's start. And I again ask my question. What is the energy of photon or energy of light wave or any wave? Energy of photon, how do you calculate it?
HC by lambda.
Okay, now we are back. Congratulations. This is what you must have done yesterday. H C by lambda, or I can write it as H multiplied by F. Yes or no?
Yes, sir.
And we have also seen a very good shortcut that instead of writing it at SC by lambda, I can write it as
HV.
that I've already done.
HF.
That I've already done. See, that is the problem with doing it in 2 minutes and doing it.
12,400 by lambda.
See, now you recollect. It will not make any sense of what we are doing in the class, bacha, if you don't study before coming to the class, and that is one thing that you never forget in your entire life. And this is valid more when you get into your college, because if you just forget what you had done in the previous class, what sort of doctors you will become. Because just before the surgery, you will go back and see how this surgery has to be done, because I've forgotten it. No, no, no. Not possible. You can't do that. Can you do that? No, you can't do that. Anyways, I hope you take this lesson seriously and follow it. 12,400. Again, this lambda has to be in which unit?
Angstrom.
Armstrong unit. And this energy that I get will be in which unit? Electron volts. And how much is 1 electron volt?
1.6 into 10 to the power of minus 19.
Now that was the answer that you are giving me for E, right? The difference between E and EV. EV is the unit. E stands for energy. Do you understand this? Your brain plays a very, what should I say, comical role in the examination hall, because you forget things before getting into an examination hall. So that's why we study. Okay, so that is what we had done in the previous class, and we had seen that that most of the questions are based on whatever question we saw. They were just simply based on this formula. We had also seen what was intensity of light wave when it falls. What is intensity? What is the what is the intensity of light waves or light ray, whatever you call it? How do you define intensity? Light falls on a surface. What do you mean by intensity of this light?
E by 80.
Yeah.
E by 80.
Energy falling per unit area per unit time. We recollect this, yes or no?
Yes, sir.
Good. Energy divided by time becomes power. So this is power divided by area, power per unit area, right?
Right, sir.
Okay, we had solved the problems based on this, and I hope you remember those problems and you remember those shortcuts. I'm not going to get into that, because if I just tell you everything in detail in this class becomes the previous class, and in that way we'll not further proceed at all. So I'll just take a pause here. And what will I do in the pause? We'll have to move ahead in our lives. Time only moves forward in life. So we also will have to take that path and move forward in our lives. Whenever possible, we will take the time machine of Doraemon, which is your what? Notes. And we'll try to go back in the past and see what we have done. The less we get back into the past, the better it is for us, because if you keep looking back, you will not move forward, because then you will not see. If you don't see, you will not move forward. So we'll have to move forward, and then we move forward to this important experiment, how this photoelectric effect was studied by Leonard. We have seen that it was discovered by someone, it was studied by someone, and it was explained, or the equations were given by someone else. Can you explain what is happening here? Looking at the diagram, can you explain what is happening? Don't read anything on the left hand side. Can you explain what is happening in the diagram? If you understand that, well, my job is done. Now, let me ask you this: have you received this note with you? You got this notes, this sheet?
No, sir.
No, sir. No, sir is a very bad answer, sir. Always yes, sir is a good answer. Okay, I'll again find out why this has not happened. Anyways, looking at the diagram, do you understand what is happening? Fast. I don't have the time of the entire universe. Tell me, what is this? What is this?
Photons.
Yes, these are light waves or photons. Photons are falling. Falling on what?
On cathode metal.
On cathode. So this is some metal surface, a photosensitive metal. This is falling on cathode. Cathode means it is negatively charged. Yes or no?
Yes, sir.
Well done, sir. So if there is a cathode, there has to be an anode. So I have an anode and I have this. What is this G?
Galvanometer.
Why? What does galvanometer do? Fast. When you are discussing this, you're also drawing it. I hope. That is what you call multitasking. You also draw and you discuss. You also draw and you discuss. You also draw and you discuss.
It
Yes.
shows that reading of current.
Reading current. So as you can understand, this is a galvanometer. That means the current might be very, very less, but still there is a current, right?
Yes, sir.
What is this? Source of power, battery. Yes or no?
Yes, sir.
So now this is what Leonard does in a
Circuit.
yes, to complete the circuit in a vacuum tube. He is going to study what happens. So he has a small window over here. You understand this green thing is a window. It's not drawn there. It's a window over here. Small opening from where light can enter. Then what happens? Light falls on a plate, cathode, photosensitive material. Energy is falling onto it. Electrons will be emitted. Electrons are negatively charged. That is why I made this negatively charged. So they will push it. The negative potential will push it and they will start to move towards the anode, and voila, we have our photo current. Yes or no? That thing is known as photo current. Yes or no?
Yes, sir.
And that thing that causes that thing that are known as photoelectrons. Yes or no?
Yes, sir.
And the entire effect is known as
Photoelectric effect.
photoelectric effect. That is correct, my dear friend. Now he did an experiment, and thank to Leonard that we don't have to repeat the experiment. We can only study. We have to only study the experiment and what happens in the experiment. That is only 3 or 4 things you have to remember, and this entire chapter is done. All the questions are just based on these. And as I told you, these NEET people, this medical exam wala people, they are very lazy. Why they are lazy? Because they don't create new questions. They only give you the questions which have already come. Yes or no?
Yes, sir.
Yes, sir. So we only 2, 3 or 4 questions, and we have done almost all the questions that are possible in this entire universe that can come in your NEET ka 2022 ka paper. So now, as you can see, there is one thing here. Which here? There is one thing here, which is this battery, right? What is this battery going to do?
Supplies the energy source.
Okay, this is going to give it the potential difference. Yes or no?
Yes, sir.
And because of this potential difference of this current will flow or current may not flow. Yes or no?
Yes, sir.
But sir, that's it, sir. And we have made it that arrow is also there. That arrow means that this is variable. Yes or no?
Yes.
So we are basically going to vary the potential difference. Yes or no?
Yes, sir.
That's it. Now, what are the observations that he made? And the observations are pretty damn simple. If VAC is kept to 0, a very small current is observed. If I just keep the potential almost 0, I see a very small current. Is it clear that why this current coming? Because photoelectrons are moving from the negative terminal to the positive terminal. Why they are moving? It's not moving because this cathode is pushing them. It's moving because energy is falling on them and electrons are released. When they are released, they will not keep in their place. They have energy. So what they will do? They will start to move. Yes or no?
Yes, sir.
That is why they are moving. Now what I'm going to do now? I am going to increase the value of this VAC. So I'm going to make A more positive and C more negative. Do you understand this? So I'm going to create a potential difference between A and C.
Yeah, sir.
And what do we see? That the photo current will increase. Yes or no? Because now electrons are going to be repelled by the negative pole and attracted by the positive pole. We all understand this, right?
Yes, sir.
But nothing comes for free and nothing always keeps on going, because then universe will not work. This current cannot keep on increasing always. There is a point where it gets saturated. Do you understand the meaning of the word saturated? It becomes constant. It will not increase at all. Yes or no?
Yes, sir.
That's it. So this yellow thing is the only thing that you must remember, and we're done. But here a question will come. So what happens if I reverse it? Now, what do I mean by when I say reverse? If I make this gentleman, this gentleman, so I make it red. If I make the gentleman opposite, if I make this as a positive terminal and this as a negative terminal, what happens then? So basically, I've reversed the polarity. What happens then? Now the opposite effect is going to happen. What do I mean by the opposite effect? That electrons which were previously repelled, now are they are going to get
Attracted.
Now what will happen if I keep on increasing this potential? I make C more and more positive and A more and more negative. What will happen? It's common sense. Common sense is physics, and that is the good thing about physics. It is common sense. What will happen if I make the opposite? If I make C, which is the plate, which was cathode, as anode, and the other thing as cathode, what happens? There will be a potential. There will be a potential where the current becomes zero. Yes or no? Because whatever electrons are trying to move, I push them back. Come back. Where are you going?
Yes, sir.
That's it, sir. So that is the next thing that you remember. First, you remember what happens when it is positive. Then you remember what happens when it's negative. You also remember what happens when it's zero. When it is zero, the current is very, very small. Do you understand? We have seen this, right? Positive, negative, zero. So we have done all the three cases. Yes or no?
Yes, sir.
Yes, sir. No, sir. So this becomes very dark, sir. When the anode is kept at the negative potential with respect to cathode, the current decreases. Can you see this, or this has become too dark for your liking? Shall I make it lighter, softer? Can you see this? What I've underlined?
Yes, sir. It's visible.
No, let it be more visible. I don't want you to stress your eyes, but so I'll make it pink. Pink is a good color. I love pink. This now comes up. Okay, so when an anode is kept negative with respect to the cathode, IP, why I and why P? I standing for current and P standing for
Potential.
photoelectric. P, photoelectric current. P standing for photoelectric.
Okay, sir. Okay, sir.
Decreases at a certain negative potential. This photoelectric current becomes zero. If it becomes zero, it has been stopped. Current has been stopped. And that potential is known as stopping potential. Do we understand this?
Yes, sir.
That's it, sir. That is what you have to understand. At this stopping potential, the most energetic electrons are stopped. It means that the stopping potential is the measurement of kinetic energy of photoelectrons. The last line that I've read, you may not understand this, but do you understand the meaning of do you understand the meaning of stopping potential? Yes or no?
Yes, sir.
So you will write up till here. You'll also write this last line. I understand that you might not have understood this, but you will write it because it will start to make sense in the next point, or maybe after the next point, or maybe after the next point when you see what is going to happen. Okay, so I'll give you a minute. I hope you have already drawn the diagram. That diagram is important. Do not leave it for your self. When we get the notes, we'll see it. Just draw the simple diagram and write what are the inferences that we have drawn. The yellow inference, the pink inference, and the tick wala thing. Write this as point number 1, point number 2, point number 3. These are the 3 points that will come in your exam. Sometimes this one, sometimes that one, sometimes this one, sometimes that one. I'll give you a minute, 2 minutes. Have we done this, bacha?
Yes, sir. Completed.
Completed, sir. Then, sir, next thing, sir, then the more important thing of this chapter, where most of the questions are going to come, is based on graph. So we have a graph here. Do we see the graph? Do we see the graph, bacha?
Yes, sir.
Yes, sir. So we have y-axis and we have x-axis, sir. So what is there on x-axis, sir, and what is there on y-axis, sir? Before going into that, sir, you also write this formula, sir. You may not understand this formula, sir, but you will just write it now. What does K stand for? Oops. What does K stand for?
Kinetic energy.
Of what? Kinetic energy of what?
Of photoelectron.
Yes, good, good. Now you are getting it. So let us call it as electron. These are photoelectrons. So when these electrons are liberated, released, they have some energy. They have kinetic energy. So we are talking about this kinetic energy of these electrons. This kinetic energy of electrons, you can find out by multiplying E. What is small e here? Small e here is charge of an electron. And what is V naught?
Stopping potential.
Yes, my dear friends, it is stopping potential. And I will tell you more about this. Just give me some time. I will tell you more about this. Right now, you just write what. Have you seen this formula before?
No, sir.
Oh, sir. Every day is a new day, sir, and every day you learn something new, sir, and that is how you become smart, sir. One day you'll become MBBS, MD, DM. That's how life goes on. Anyway, let us come back to the graph that we had seen, and I hope you are writing everything that is written here. Do not trust that you will get the notes and then you will read. You cannot become a doctor or engineer just by reading physics, because physics is one thing that never counts by reading. It is done by your hard work, and that is why physics pays. Okay, so I have a graph here. I have an x-axis, I have a y-axis. What is drawn on the x-axis and what is drawn on the y-axis? And then I leave it to you, to your common sense. Common sense is physics. With common sense, you can tell me what is there on the x-axis and what is there on the y-axis. Tell me what is there on the x-axis, what is plotted on the x-axis, what is plotted on the y. I don't have the entire time in the universe. I have to move on. Tell me.
On
What is plotted
x-axis,
on the
maximum.
What is plotted on the x-axis? That tell me that.
JEE of electrons, kinetic energy of electrons.
No, that is not plotted.
Charge.
I have VAC, potential difference between A and C. That is plotted on the x-axis. If it is positive, current increases. If it is negative, current decreases. And at some point, it becomes zero. Do you understand this?
Yes, sir.
Then, if I have told you one part that potential between A and C is plotted on the x-axis, now can you tell me what is plotted on the y-axis? You must remember the heading of this point. The heading of this point was the effect of potential difference between A and C. Yes, so what is plotted on the y-axis? The thing that is plotted on y-axis is IP. What do you mean by IP? What do you mean by IP? Photoelectric current. Do we understand this? So when I increase the value of potential, what happens? The value of current increases. Yes or no?
Yes, sir.
And then, sir, it reaches a maximum value, sir. Yes, sir. And that maximum value is known as saturation current. I standing for current, S standing for saturation. Do we understand this?
Yeah, sir.
When the potential difference is zero, you can see a very large current, but the scale is very small. So the current is very small. And if you make the potential negative, that means you make the anode negative, you make the anode cathode. What will happen at some point in time? Current will stop. Yes or no?
Yes, sir.
Which is the point where the current stops? Can you see that point?
Stopping potential.
Yeah, so this potential becomes V naught. I can also write it as minus V naught because it is negative. Do we understand this?
Yes, sir.
Yes, sir. Then, sir, what do you do, sir? You draw the graph and you stay happy. 1 minute. Let me know when you are done.
Completed, sir.
Completed?
Yes,
Then
sir.
comes
Completed.
the next point, effect of intensity of light. Tan, tan, tan. Intensity of light. Now, it is very important for us to understand the meaning of intensity of light. I think we have already done that. What was intensity of light? Let us go back and go back in the past, get your time machines, become Doraemons, and get back in the past. What was intensity of light?
Power by area.
Yes, so basically it tells us how much energy is falling per unit area per unit time. Okay? Yes
Okay,
or
sir.
no?
Yes,
Now,
sir.
now this is where it might get a bit confusing. So I'll try to make more sense out of this. How can I increase intensity of light? Or what do I mean when I say I'm increasing the intensity of light? Obviously, I am not going to change the area on which it is falling. So decrease the area, intensity will become more. Let us not talk about that. The question is, how do we change the intensity of light? Now remember, what we are assuming here is light consists of small particles. Small particles. And what I'm going to do is show you a small particle and then. Do you see this? I have a small grain in my hand. Yes. So this is, let us assume that this is a photon of light. Okay. Now this photon of light has an energy, right? Yes or no?
Yes, sir.
Yes, it has an energy. How much is that energy of this photon, small photon that you see?
1.6 into 10 to the power of minus 19 joules.
Hc by lambda. Please don't forget it. It is Hc by lambda. Do we understand this? Yes or no? The same answer you have given in the previous, in the first case. Do you understand that this has an energy Hc by lambda? Yes or no?
Yes, sir.
Okay. Now remember, this one photon is not going to fall here. When I say light is falling, and you can see light falling on my palms. Yes or no? Obviously, one photon is not falling. There are a number of photons that are falling. Yes or no?
Yes, sir.
Now, when I talk about the intensity of light, I want to increase the intensity of light or decrease the intensity of light. How do I do it? What should I do so that I make more light fall on this? How can I make more light fall on this? My hand. How can I make more light fall on this hand? Which will be, if I increase the light falling on this hand, I will increase the intensity. Yes or no?
Yes, sir.
How do I do it? Light consists of this. Light consists of this photon. How do I make more energy fall on this? I have photons, chota photons. Tell me, how do I do it? If you understand this entire chapter is done. We don't have to do anything else. Tell me, bacha, how do I increase the intensity of light that was falling on my hand? How do I do it? Simple. It's common sense. It's not physics. Intensity of light can be increased by, I want more light to fall on this. This is the bulb. This is throwing photons all over the place. I want more light to fall here. What do I do? I increase what? Increase the
Intensity.
अरे बच्चा वही तो पूछ रहा हूं मैं. How do I increase it? This intensity depends on the number of what?
Falling lights.
Yeah, the number of falling lights. Instead of calling it falling lights, what I will call it? Number of
Photons.
photons. So intensity of light. And if you go back to the formula using your time machine, you will see it was n number of photons. Yes or no?
Yes, sir.
That's it, sir. So if I have to change the intensity of light, I want more light to fall on it. What do? I make more photons fall onto it. Got it?
Yes, sir.
So intensity. Now, how do I understand intensity? I will not understand it in terms of energy per unit area per unit time. But to understand from here onwards, how do I imagine intensity of light as? What is intensity of light? On what thing intensity of light depends on? It depends on
Number of photons falling.
number of photons falling. And that is why the formula, you will always remember that formula. The intensity of light depends on more light falling on it and not more energy wala light falling on it. You understand this?
Yes, sir.
More light falling on it, not more energy wala light falling on it. It's like I have 10 photons falling on it. Instead of making it 10 photons, I'm making 1,000 photons. 1,000 photons are falling, obviously, more light. But these photons may have different energies. How do I change the energy of a photon? How do I change the energy of a photon? This photon. This one. How do I change the energy of this? Again, the same question. On what factor? By changing the
1.6 into 10 to the power of minus 19 energy.
फिर वही आ गया उसी पे. How do I change the energy of a photon Energy of a photon is given by which formula, beta?
hc by lambda.
Yes, instead of calling it hc by lambda, instead of saying 3, I can call it as h into f. Yes or no?
Yes, sir.
What is f here, sir?
Frequency.
So how do I change the energy of a photon?
By increasing frequency.
By increasing or changing frequency. I make more energy wala photons falling by changing the frequency. I make more photons falling by changing the number. Do you understand the difference between the two? One is changing the number and one is changing the frequency. Do we understand this?
Yes, sir.
Everyone understands this? If you understand this, this chapter is over. We don't have to do anything else. The rest of the chapter is just an implication of these two things.
Once more, sir.
If I change the number of photons, what do I change? Say. If I change the number of photons, what do I change? It is written in the samne wala screen. Yeah, read it and tell me. If I change the number of photons, what do I change? Read it. You can see the screen, no? Or you only see my stupid face? You seen the screen, no? Right in front of your eyes?
Yes, sir.
What do I change by changing the number of photons?
Intensity.
Intensity. What do I change by changing the frequency? Number
Energy.
2, energy. That's it. Energy of light, energy of photon depends on energy of photon depends on the frequency of photon. Intensity of light, intensity depends on number of photons. Please note it down in your books. Important note. What is the important note that we are discussing, bacha? What is what I have said?
Intensity depends upon number of photons.
Yes. What is the second thing that I said? What is the second thing, bacha?
If we increase frequency, energy also increases.
Yeah. So basically, what do I write? I write it as star. Important point. What is the important point? Oops. What is the important point? I have not resumed share. What is the important point?
By increasing frequency, number of photons also increases.
Number 1, intensity of light, bacha. Intensity of light. And this is how you will write it. Intensity of light depends on what?
Number of photons.
Yes. Now we are getting somewhere. Number of photon. Intensity of light depends on the number of photons. You want more light. Intensity means more or less light. More intensity, more light. Less intensity, less light.
Less light.
Yes. What is the second thing about light that you are concerned? The second thing about light that you are concerned is energy of light. How much energy this light has? Energy of light or energy of photon? It depends on what, bacha?
Change in frequency.
It depends on the frequency of photons. What frequency they are falling. More the frequency, more the energy, more the number, more the intensity. Am I clear?
Yes, sir.
Absolutely clear. If you forget this, the entire chapter is gone. If you forget this, the entire chapter is gone. If you remember this, the entire chapter you will recollect in 1 second. I'll give you a minute to note this down. A minute to note this down and remember it for the rest of your lives.
Done, sir.
So are we done with this?
Yes, sir. Completed.
Yes, sir, completed. Now, what we need to understand before going on to the next thing, and let me share this with you. What we need to understand before we move on is something that we know as, let me bring that on your screen right now, right now, right now, right now. Where is this? Where is this? Where is this? No, I don't see this. Strange. Okay, I don't see this. So what I do, I just remain on this sheet because it becomes important for us to understand this. Okay, do you see? Do you see my screen? See now? Okay, the next thing that we should understand before going any further is something known as work function. Work function. We can call it as W naught or W, whatever. Work function. Ever heard this term, work function?
Yes, sir.
Yes, sir. Then tell me, what is this, sir?
The energy required to remove electron from a metal.
Yes, that is absolutely correct. So it is something like an ionization energy. No, something that you can relate with is ionization energy. Work function is something like an ionization energy. If I have to liberate electrons from any metal, any surface, I need to give it some minimum amount of energy because they are closely held by the nucleus. Nucleus doesn't want to let them go, just like a mother or a father does not want their child to go away. They are holding on to them very tightly. But then some external agent has to come, and in case of guys, this is his wife, and in case of girls, it is her husband that pulls them away and takes them from their parents. Some minimum amount of energy is required. That amount of energy which is required to remove an electron is known as
Work function.
And that is what you write. This is the minimum amount of energy. Minimum energy required to do what?
Remove electron.
Required to remove electrons or release photoelectrons. Do we understand this?
Yes, sir.
Something like ionization potential or something of that nature. Now, when it will be easier to remove electrons and when it will be tougher to remove electrons, so we can understand in terms of work function. If work function is very high, then if work function is very high, then tell me then what?
More electrons are removed.
If work function is very high, it is more difficult to remove electrons. Yes or no?
Yes, sir.
We understand this, sir. This is common sense, sir. Yes or no?
Yes, sir.
Okay. If work function is more energy is required. If work function is less energy is required. Yes or no?
Yes, sir.
Now let us take the example of this is my metal sheet and I want to remove electrons from this metal sheet. Okay.
Okay, sir.
Now to remove electrons, I must provide it with energy so that I can remove electrons from here. Now there are only two ways in which I can give it energy. I can change the number of photons which relates to intensity of light, and I can change the frequency of photons which relates to the energy of photon. What should I do to make electrons released from this metal surface? What should I do? Should I change intensity of light or should I change the energy of light or energy of photon?
Number of photons.
Number
Intensity
of
of light.
photons, and that is the wrong answer, my dear friend. Think.
Frequency of photons.
Yes. So you only had two options. So if one is wrong, the other one is correct. But there has to be a reason behind it. And the reason is pretty damn simple. The reason is common sense, and common sense is physics, and that is why physics is good. Physics is easy. For example, the work function of this metal, let us say, work function is normally in electron volts, but you may, oh, electron volts, sir. Make it simple. Work function is 1 joule. I need 1 joule of energy to remove photons from to remove electrons from here. Now what do I do? I make light fall on this. I make 1 million photons fall on this. Oh, बहुत सारा photons. But the energy of one photon is only 0.5 joule. And I make, oh, let me make more photons fall. But the energy of one photon is only 0.5 joule. Will it be able to liberate electrons? Will it be able to liberate electrons? And the answer is 1 million photons are falling. The energy of one photon is 0.5 joule, but the work function of this gentleman is 1 joule. Will I be able to liberate electrons? Yes or no? And the answer is
No.
no. You will not be able to liberate electrons. Why? Why I will not be able to liberate electrons? Because the energy of a photon that is falling is less. Are we getting the point?
Yes, sir.
Yes, sir. No, sir. Then how do I understand this, sir? To understand this, what I'm going to do is, again, I'm going to draw a diagram. And my diagrams are normally very illustrative. So this is what? What is this? This is a gola, sir. This is not a gola, sir. And what is this? This is again gola, one gola, sir. This under wala gola is my nucleus. And it's a very primitive elementary diagram that a third standard kid can draw. Even my son can draw this. He's only in the first standard. And then this gentleman is here. So you understand the gentleman. This gentleman is your electron, yes or no?
Yes, sir.
And this electron is going down. Now I want to liberate this electron. And I want to liberate this electron. So I'll have to give it energy, right? Yes or no?
Yes, sir.
That energy was previously known as ionization energy. Right now we will call it as? Right now we will call it as? Arey? What is the heading? Read it.
Work function.
Is that a question or is that the answer? I want to liberate this electron. I want to make it free. Do I need to give it energy? Yes or no?
Yes, sir.
What that energy is now known as? What do I call that energy that I have to give it? Work function. Do we understand this?
Photoelectric energy.
अरे work energy, work function यार. अभी तो अपन ने we have gone through this. There was a movie known as Ghazni. Have you seen that movie Ghazni? Starring Amir Khan. It's a remake of a very good Hollywood movie known as Memento. And in that movie Ghazni, what happens is like this gentleman, Amir Khan, the hero of the movie, he forgets what had happened 5 minutes before. Now, if we all become Ghaznis here, and you forget what has happened 5 minutes before, and imagine that you are doing a surgery and you have forgotten what you have done 5 minutes before, Will that surgery ever succeed? No, na? We can't forget what we have done 5 minutes before. We can't become Ghazni and we can't become doctors then. Because I will not give you the medical certificate if I know that you are a Ghazni. So do you want the medical certificate? So tell me what that energy is known as, which is required to liberate this electron. That energy is known as? That energy is known as?
Work function energy.
That energy is known as?
Work function energy.
Work. You don't call it work function energy. You can simply call it as work function. We understand this? So I need some energy to liberate this electron. Now, how is this energy going to come? I'm going to make light fall onto it. Now, how does this light liberate this electron? To understand this, what I'm going to draw this chick. What is this chick? What is this? What is this chick that I've drawn? That green thing. That red thing is your electron. What is that green thing? That green thing is your
photon wavelength.
Not wavelength. I've drawn the diagram of a photon. A photon does not move like this because they move in a straight line, but just to make it more fascinating that it moves like this. It has some twists and it can dance, it cannot dance, it just moves in a straight line. Light moves in a straight line. Just an illustration. So this is a photon. Now one photon is going to fall on it and it is going to liberate this electron. So this photon is your spouse. This is your mom and dad. Nucleus is your mom and dad. Electron is the child. It may be a girl child, it may be a boy child. It is holding it tight. And this photon is a gentleman who is trying to take them away. So do you understand how this electron is liberated? Yes or no?
Yes, sir.
Now I want this electron to be liberated. Now what do? I make more photons fall onto it. That will liberate this electron. Or I make the energy of the photon more to liberate it. I have to make the energy of the photon more. Yes or no?
Yes, sir.
So energy of this photon has to be more than what? If I call the energy of this photon as E, energy of this photon as E, this has to be more than what? To liberate this electron. This electron is held together by the nucleus. Parents, don't go anywhere. Stay with us. Photon comes now, I'll take her away or take him away.
Energy of a proton is more than electron.
Energy of the photon is more than?
Energy of electron.
It should be more than the work function. Does it ring any bell? The name of the heading is work function. Work function is the minimum energy required to remove an electron. If I want the electron to be removed, the energy of the photon has to be more than work function. Does it make sense?
Okay, sir.
Okay, it makes sense. Or in worst case, it must be equal to the work function. If it is equal to the work function, this electron will get liberated, but it will have no energy at all. Do we understand this?
Yes, sir.
Well done, sir. So this electron gets liberated. So this jig red wala is the electron getting liberated. The girl getting separated from her parents or the boy getting separated from his parents. And this photon is the agent that is going to do it. But this agent has to do some work. It must have sufficient energy for the electron to be liberated. So this energy has to be more than this work function. Now, when this electron gets liberated, it has some kinetic energy. Do we understand this?
Yes, sir.
Yes, sir. Because it is liberated, it is moving, it will have some kinetic energy. So this is how an electron is liberated by light which is falling, or energy which is falling on this metal. The energy of the photon has to be more than what?
Work function.
That's so I can only liberate electrons if photon has a certain minimum energy, and that certain minimum energy is known as your work function. Will you remember this?
Yes, sir. Definitely.
Well done, sir. Now, Since we are talking about the energy of this photon, now see, everything just relates. Physics is all about relating things. This electron is the girl or boy, and the nucleus is your father or mother or parent. Now this energy of the photon is related to what? How do I change this energy of the photon? The gentleman who is trying to liberate. हमें चाहिए आजादी. We need freedom. So this freedom, gentleman, what is this energy of the photon related to? It is related to its. Don't become Ghaznis, because that will not serve any purpose. You will forget what you have done in the surgery 5 minutes before, and the life of the patient is at risk. Tell me, what is the energy of the photon related to? I gave you a minute, entire 2 minutes to write it. And I told you, if you remember these two things, you are done with the chapter. If you forget these two things, you are also done with the chapter. One in the good sense, other in the bad sense. What is the energy of this photon related to? How can I change the energy of this photon?
Frequency of photons.
Yes. It relates to the frequency of photon. So that means there has to be a minimum frequency which corresponds to a minimum energy which is required to liberate electrons from this metal. There must be a minimum frequency. Do we understand this?
Yes, sir.
Yes, sir. So what do we call that frequency? We don't call that frequency as work function frequency, because it does not look good. So we have a different name for it. The falling photon, that green gentleman, jug, green gentleman, should have some minimum energy which comes from a minimum frequency. That minimum frequency, oops, wrong color. That minimum frequency of photon, I hope everyone is writing this, that minimum energy of photon which is required to liberate electrons should have some name. Yes or no?
Yes, sir.
And that name is known as? That name is known as threshold. Have you heard this term, threshold? Threshold frequency. Do we understand this? Yes or no?
Yes, sir.
So this minimum energy, which should be more than the work function, corresponds to a minimum frequency. That minimum frequency is known as threshold frequency. That minimum energy is known as work function. Minimum frequency is known as threshold frequency. Minimum energy is known as work function. Will you remember this?
Yes, sir.
I'll give you a minute, an entire minute, to note this down. Please note it down. I hope you are drawing the diagrams as well. Yes or no?
Yes, sir.
Well done, sir. A minute to win it.
1 minute. Completed.
Well done, sir. And remember, this energy of this photon that we know, this energy is directly proportional to frequency. Yes or no?
Sir.
But at the same time, this energy of the photon is inversely proportional to wavelength. Do we remember this from the previous class? Going back in the past, becoming Doraemons in the time machines.
Yes, sir.
So if we require minimum energy, which comes from minimum frequency, what will be the relation of this energy with the wavelength? Frequency was minimum, so wavelength has to be? Frequency is minimum, so wavelength has to be maximum. Do we understand this? Maximum wavelength or maximum lambda of photon which is required to liberate electrons. This maximum wavelength, which is minimum frequency, is known as threshold. You can't call it we can't call it frequency, right? So we'll call it as threshold wavelength. Do we understand the meaning of threshold frequency and threshold wavelength?
Yes, sir.
A minute, 2 minutes. Have you written this, bacha?
Yes, sir.
Now, a simple question.
Sir,
Yes.
what is the effect of temperature on work function? Okay, sir. Okay.
Temperature is in thermodynamics. Let us not get into that.
Okay.
The work function does not depend on temperature, bacha. Is a property of the metal. Now, when you are increasing the temperature, you are in fact giving it energy. That does not change the that does not change the work function of the metal. Do you understand this? They have no relation at all. Okay.
Okay, sir. Okay, sir.
So now I can formulate a relation. Now this threshold frequency, gentlemen, I will write it as F naught. Do we understand this? This not meaning threshold, not F naught. So this threshold wavelength I will write as lambda naught. Do you understand? The symbols are important because symbols mean everything to me in physics. F naught stands for threshold frequency. Lambda naught stands for threshold wavelength. Will you remember this?
Yes, sir.
Now I have a relation. Now I have a relation between what? Three things we have seen here. What are the three things that we have seen here? Again, don't become Gaznis. We just done it 2 minutes before. There are three new terms that have come to us in this discussion. What are the three new terms? The first one was
Intensity of light.
what? The first one was work function. You always forget it. The second one was threshold frequency. And the third one is threshold wavelength. What is the relation between W naught? That's why I used not there because I had to relate it. F naught and lambda naught. Can you tell me how are these three things related to each other? I'll give you a minute. A minute. A minute. 2 minutes. If you can do this on your own, I would be very glad, and then you will not have to remember it because you have done it with your own hands. And you can do it because you know all the things that you need to know to give me this relation. Relation between W naught. What does W naught stand for?
Work function.
What does F naught stand for?
Threshold frequency.
What does lambda naught stand for?
Threshold wavelength.
And you have 1 minute to tell me the relation between the three. Your time starts now. And I will do some drawing. I like drawing. The time starts now. What could be, would be the relation between these three? And it does not take rocket science to understand this. Even rocket science is very simple. The only thing that is troubling physicists right now is quantum physics. And we are not studying quantum physics here. It's simple physics. Yes, my dear friends. Are you trying or shall I reveal the answer?
Work function is equal to H frequency is equals to Hc by lambda naught.
Well. So W naught, which is the work function, should be equal to, yes,
H mu naught wavelength
H into F naught. Well done. And that must be equal to?
Hc by lambda naught.
Well done. That is the relation that we were looking at. Do we understand this, everyone, in the class? Can I have some reason that we understand this?
Yes, sir.
Energy relates to the frequency. And how does energy and frequency relate? H into F. So if it W naught, which is work function, that has to be equal to H into F naught, and that should be equal to Hc by lambda naught. Yes or no?
Yes, sir.
Okay, sir. Then, sir, what do we do, sir? Next, sir, what do? We understand what happens. 3 cases, so important cases. Number 1, if E, the energy of the photon, is greater than work function W naught, or I can write it as F. What does F stand for? The frequency of the is greater than F naught. Do we understand the meaning of the symbols?
Yes, sir.
Or lambda. What does lambda stand for?
Wavelength
of the photon is smaller than lambda naught. Do we understand this?
Yes, sir.
Then what happens? Electrons are liberated and they have kinetic energy. Yes or no?
Yes, sir.
Then electrons are liberated. Electrons are liberated with some kinetic energy. Do we understand this?
Yes, sir.
Yes, sir. That is the case. That happens, sir, when energy of the falling photon is more than W naught. What could be the second case? And again, it is all common sense. Physics is all common sense, and we all have common sense. And that is why physics is very simple and very fascinating to read. What should be the next case? Ting, 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 ting. One is energy greater than W naught. What should be the next case? Simple. Huh? What will be the next case? Are
E is equal to W naught.
Yes. See, now you are thinking like a physicist, and that is great. If E is equal to W naught, or the other way I can write it as
F is equal to F naught.
F is equal to F naught, or the other way in which I can write it as lambda is equal to lambda naught. Then what will happen? Now it is all common sense. Common sense is physics, and physics is fascinating. What will happen now?
Zero kinetic energy.
But electrons would be emitted. So I'll just write electrons are liberated with zero. No hero, here only zero, with zero kinetic energy. Do we understand this?
Yes, sir.
Yes, sir. No, sir. Then come, sir. The next topic. No. The next case, sir. What would be the next case, sir?
E is less than W naught.
See, we understand this now. E is less than the energy of the photon is less than the work function. There might be 10 million photons falling on the metal, but the energy of one photon is less than one's work. See, we are not dealing with numbers here. More photons does not mean that electric current, that photoelectric current will happen. It depends on the energy of the photon. Do we get this idea?
Yes, sir.
If energy of the photon is less than work function, or the frequency of the photon is less than F naught, or third case, lambda is greater than lambda naught. Remember, this is the reverse case. Do we understand that relation here? Reverse case scenario, na? If F is more than F naught, here it was lambda is less than lambda naught. Here it is F is less than F naught, or lambda is greater than lambda naught. We understand this? We have this idea, yes or no?
Yes, sir.
Then what will happen? Electrons will be liberated with negative energy. Can anyone have negative kinetic energy?
There is no.
They cannot have negative kinetic energy, right? That
Yes,
means
sir.
the electrons, are they going to be liberated?
No.
Yes, that is the answer. Electrons are not liberated. Electrons are not liberated. You cannot liberate electrons. You cannot free them. No matter what,
Correct.
no matter the number of photons. You may have 10 million photons falling, but if the energy of the photon is less than your work function, there will not be any photoelectrons which are emitted or liberated. Do we understand this?
Yes, sir.
That is the most important thing of this chapter. If you understand these things, the entire chapter is done, my dear friends. Don't have to do even a single question. The entire chapter is done and dusted. Do we understand this? Yes or no?
Yes, sir.
This is the time where you show me your talents, and your talent is in writing all these notes. Are you writing all these notes?
Completed, sir.
Completed, sir. Then you come to the oops, garbal. I shared the wrong screen. It happens in life that sometimes garbal happens. So when garbal happens, you just change the garbal. So now we were doing what is the effect of various things on photocurrent, and in that I took a break and we understood work function. Now we again come back to what is the effect of intensity of light on the photoelectric current. So what do I have? I have a graph, and I have here on the x-axis I have plotted VAC. Do we understand this? In the first graph, and in the
Yes,
second
sir.
graph I have plotted intensity. Do we see this, bacha? Here I have plotted VAC, and there I have plotted intensity. Yes or no?
Yes, sir.
Yes, sir. What is the relation between intensity and current, and intensity and anything else? So if I increase the intensity, as you can see, if I increase the intensity, what happens to the current? The current will increase. Why will the current increase? Because if I allow more photons to fall, more electrons will be liberated. Do you understand this?
Yeah, sir.
Intensity relates to number of photons. More photons, if I only make one photon to fall, how much current I will have? I will have only one electron. Yes or no?
Yes, sir.
If I have 10 million photons, I will have 10 million electrons. Yes or no?
Yes, sir.
More electrons means what? More electron means what? More will be the current. Yes or no?
Yes, sir.
But the energy of the photon must be more than what? But to have this case, energy of the photon must be more than?
Work function.
Yes, then only it will happen. The first case is frequency must be is energy must be more than work function. If the energy is more than work function, more the light, more the number of photons, more is the electrons, more is the electric current, and that is why we have a direct relation. Is this diagram clear to all? The right hand side one?
Yes, sir.
Yes, sir. No, sir. Yes, sir.
Yes, sir.
Okay. Now we come to the left hand side wala diagram. In the left hand side wala diagram, there is a diagram between potential difference and electric and photoelectric current. We have already seen that diagram. Do we remember this diagram? Yes or no?
Yes, sir.
Now what I have done, I have changed the intensity. In one case, the intensity is I1, And in the second case, intensity is I2. Intensity I2 is more than intensity I1, but the frequency is same. Do we understand this?
Yes, sir.
The frequency is same. So if I have more intensity, you will have more current, you will have more saturation current, yes or no?
Yes, sir.
And therefore the diagram is like this. Do we understand the left hand side wala diagram?
Yes, sir.
Do we understand the right hand side wala diagram?
Yes, sir.
Congratulations, you have done almost 1/3, 2/3 of this chapter by understanding these two diagrams. I'll give you a minute to draw this diagram. I hope everyone has understood it. Yes or no?
Yes, sir.
A minute to win it. Please let me know if you have noted it down.
No, sir.
I'll wait.
Clear, sir.
Noted it down, everyone. Then comes the next effect, and the next effect is the effect of frequency. Now, when we have, again, I have two diagrams here. First diagram between frequency and V naught. What is V naught here? Stopping potential. Do we remember this stopping potential? Do we remember stopping potential? The potential
Yes,
which
sir.
is required to stop the current. Okay. So I have frequency on the x-axis and stopping potential on the y-axis. Do we understand this?
Yes, sir.
If the frequency is less than f naught, nothing will happen. Yes or no?
Yes, sir.
If I make the frequency more and more, if I make the frequency more and more, if I make the frequency more and more energy will fall. If more energy is falling, electrons will be going out with more energy. Yes or no?
Yes, sir.
If electrons are going down out with more energy, I will require more energy to stop them. Yes or no?
Yes, sir.
And that is why the graph is a straight line. Do we understand this?
Yes, sir.
Well done, sir. What is this F naught known as?
Threshold frequency.
Threshold frequency. Do we see threshold frequency here?
Yes, sir.
What is this lambda naught? It is not shown, but what is this lambda naught known as?
Wavelength.
Which wavelength?
Threshold wavelength.
Threshold wavelength. So do we understand the right hand side wala diagram?
Yes, sir.
Then now let us go back to the left hand side wala diagram. On the left hand side wala diagram, I have potential of A and C plotted here and the saturation and the current plotted here. Do we see this? Here I have changed frequency. Here I have changed frequency. At frequency F1, this is the diagram. At frequency F2, this is the diagram. If F1 is less, energy of electrons is less, and therefore the stopping potential is less. Do we understand this?
Yes, sir.
If frequency is more, energy is more, stopping potential is more. Do we understand this?
Yes, sir.
But here, my dear friends, the intensity is same. Now, here intensity is same. If intensity is same, the stopping potential is same. Do we see this? In the previous graph, let us see. In the previous graph, we had frequency same, intensity different. So we had two graphs which were going like this. More intensity, more up. Less intensity, less up. Do we understand this?
Yes, sir.
But the frequency was same and hence this point was same. Do we understand this?
Yes, sir.
But in this graph, the new graph, present graph, what we have done? Do we see this graph? What we have done? We have kept the intensity same. So the top side is same. Yes or no?
Yes, sir.
But we have changed frequency. So the niche wala side, this is less frequency and this one is more frequency. Do we understand this?
Yes, sir.
I'll give you a minute to note this down. The right hand side wala diagram and the left hand side wala diagram. Right hand side wala diagram, straight line. Previously also it was a straight line. Left hand side wala diagram. Previously the tops were mismatched, but the bottom was matching. Here, top is matching, the bottom is not matching. Do we understand this?
Yes, sir.
And if I have different intensity and different frequency, neither the top will match nor the bottom will match. Do we understand this?
Yes, sir.
If intensity is same, top will match. If frequency is same, bottom will match. If both are different, no one will match. Do we understand this?
Yeah, sir.
1 minute to show me your talent, and then we'll do the last point and we are done for today's class. Everyone has understood what we have done? Can I have some raised hands from everyone in the class that we have understood this? This entire chapter is done. If you understood this, the entire chapter is done. If you not understood this, then the entire chapter is gone.
Yeah.
So you will have one more day to go back, because in the next day, that is the tomorrow's day. Tomorrow's day. Tomorrow we will be doing the problems, and you can see if I do only 3 problems, the entire chapter is done, because there is nothing that is there to be discussed. You'll only get these graphs, and if you understand these graphs, everything becomes simple. Have you noted this down? Yes or no?
Yes, sir.
Noted. Then comes the last point of this, and this is very simple. Simple. Do you see this? Time lag. Time lag. There is no time lag. Why there is no time lag? Go back in the past. Time lag. There is no time lag between the incidence of radiation and the emission of electron. As soon as photons fall, electrons are released. Why? Because photons strike the electrons and electrons are released. There is no time lag. It's an instantaneous process. What type of process? It's an instantaneous process. As soon as photons fall, light falls, electrons are emitted, and that's all we need to know. This is the entire chapter. Trust me, we only need to do one more equation and the chapter is finished. Most of the questions on this chapter are going to be based on what we have studied in today's class. So before you come to the next class, what you are going to do?
Revise the notes.
Because if you don't do that and you become Ghaznavis in this class, right, your patience would be at risk. Because I have seen incidents where the surgeons have forgotten their knives and scissors inside the belly of the patient, and then they operate them again and take it out. Have you seen those incidents? Have you heard about those incidents? Yes or no? So I can't allow my students to become doctors and surgeons like this, that they forget their scissor inside the belly and then they get punished for that. So don't forget your scissors and don't forget your knives inside the belly, because that will not create a good impression. Don't become Ghaznavis. Remember what you have done and revise before coming to the class. That's all from today's class. I'll see you tomorrow. I hope you have read this, understood this, made your notes, and I'll make sure that your notes, this sheet reaches you. I don't know why it did not reach. Take care. Have a nice day. Bye bye.
Okay, sir. Bye. Take care. Have
Bye.
a nice day. Bye.